Okay, hello calculus students. Today you are working on separable differential equations, and I fielded a few email questions regarding a particular piece of this process. And actually I can see I put just gonna make one little adjustment here. That's, you know what, I'll just write this over. U of 0 is -5 on this problem. This is -5. This is question 13 from 9.3. It's from your textbook. It was just part of the practice problem. So this is not something you were expected to turn in, but it's good that you're doing the practice and you're emailing me with those questions. I think I was able to answer everybody's, but what I've learned over the years is if a couple students ask a question, quite likely many students have that same question. So I'm going to walk this through, and specifically what I'm going to talk about is the impact that this has on your final solution, and hopefully explain why it has that impact. So it's a little nuanced, and it's a really good question that you all are asking today. So first off, we're going to separate. So I'm going to do this cross multiplication deal. So I've got 2u du, and then I've got 2t plus secant squared of t dt. So separate the variables just using the cross multiplication. Then I'm going to integrate both sides. So 2u du equals 2t plus secant squared of t dt with an integral sign. And I could have, I suppose, just popped that on the same step, but it feels better to just write it out for me. So then I've got 2u squared over 2, which is just u squared on the left. And on the right, I've got 2t squared over 2, which is just t squared. And then you would have to know the integral of secant squared is tangent. That would just be one of those expectation pieces that you could generate that. And then plus c. And you know what, here's the good news. In terms of an AP free response setting, and this is what we would see this year is free response, when you're doing something like this is honestly the bulk of the points. Just going through and separating, integrating, and putting your plus c. They're looking for process. They're looking for step by step. That being said, it's important to finish out the problem. And to do that, I'm just going to write this in down here. This is that initial condition that we're given. From here, what we're going to do is we're going to take and solve for c. So we're going to plug that in to solve for c. So I'm going to say, okay, my u value is -5 when my t values are 0. And then whatever that's worth is what my plus c is. So 0 squared is 0, tangent of 0 is 0, -5 squared is 25, so my c is 25. Again, there we've picked up another point in terms of AP point structure. So you've already done the bulk of the work they want to see. The thing that you were all asking, or the questions I was getting today, was not about any of this, but it was about what happens next. So here we've got this expression u squared equals, I'll put it right there, u squared equals t squared plus tangent of t, maybe some brackets in here would be fun, plus 25. I then need to take a square root, and whenever you take a square root, you get a plus minus, which is true, which is accurate. That's not an algebraic lie you were taught when you were a youngster. That is an accurate thing. However, if you think about what a plus minus is doing, it's giving you two different y values. It's giving you a positive y value and a negative y value. That means when you write that plus minus sign, you're saying you could actually have two different values for an input like 0. So as a for instance, if we put 0 in here, so if we were to plug in and we call this our function and say, well, what is u of 0? Well, u of 0, if I put in a 0, I get 0 squared. I'll leave that little plus minus there. I get 0 squared plus tan of 0 plus 25. So then I get plus minus the square root of 25, and I get plus or minus 5. But the thing is, based on the initial condition they gave us, it's not plus or minus, it's -5. And the reason they have to delineate this is whenever you see this plus minus, you do not have a function. You have an expression that has a positive half, a top half usually, and a negative half, a bottom half, meaning it fails the vertical line test. A kind of an aside, if I just, let me see. So this would be in class, I would probably be rambling, and I'd put a little aside up here. If you solve the simpler equation, y squared equals x, you would take the square root of both sides, and then what you create, plus minus root x, is you create this sideways parabola. So there's our positive root x, there's our negative root x. This thing just is lousy with the vertical line test. It fails it over and over and over again because it has a top half and a bottom half, a positive top half, a negative bottom half. And what we're trying to do is generate a function solution. So we're trying to generate something that is u of t, or f of x equals. So here I'll kind of box in the aside as well. So this thing that we've come up with isn't a function. What we need to do is link these two starred expressions together. and we need to basically pick, are we dealing with the positive arm or the negative arm? So the top half or the bottom half. And based on the initial condition, what this one is saying is, hey, you know what? You're actually using the bottom half. So you're using the negative square root of this. And that's really it. There's not any more magic to it other than just saying we want a functional answer. To get a functional answer, you need to choose. And the way you choose is by using the initial condition. So hopefully that helps shed some light on the question I was getting today. And thanks for those questions. Please keep emailing them. I'll post this to the website as well as email it out.